Hi, in this class we will continue our study of numbers, and the next topic that we will see is called multiplication and division of two integers. So, we know how two natural numbers or two whole numbers can be multiplied, and we will now extend that concept and understand multiplication and division of two integers. The first thing we will look at is multiplication of two integers. So let me just call this multiplication of two integers. Now let us see how two integers can be multiplied to each other. Well, note that if we have two integers of the form 21 and 7, then multiplication of these two integers is simple because these two integers are also whole numbers. And because 21 and 7 are both whole numbers, we've already seen how to multiply whole numbers. But suppose if we have another case wherein we have 21 multiplied by minus 7. So this time we have one multiplicand as an integer. So this one here is not a natural number or a whole number. This is an integer. And so we have multiplication of two integers. Similarly, we can have another case wherein minus 21 is multiplied to 7. Again here this is an integer, and so this is multiplication of integers. In the final case, we can either have, or rather in the final case, we can have both the integers being multiplied are negative. So we can deal with this first case with our present knowledge wherein both are whole numbers, but in other cases when both the numbers to be multiplied are not whole numbers but they are integers, then let us see how we can deal with this situation. To deal with this situation, we have two rules that apply to multiplication of integers, and the two rules are as shown on the board. Now the first rule says that whenever two integers to be multiplied have like signs. Now we've seen that like signs means that either both integers have the plus sign or both integers have the minus sign. Now if you look at this first rule, we are dealing with like signs, and if you notice, this multiplication here is multiplication of two integers having the like sign because both signs are plus. Similarly, if you look at the fourth case, here the signs of both integers are negative. This is also negative, this is also negative. And so we are multiplying two negative integers. And so these two integers being multiplied have like signs. And so again the rule 1 will apply here. So this first case will be solved by use of the first rule. Similarly, this final case will again be solved by use of the first rule because they still have like signs. Well, let's now apply the first rule to these two cases. Now, the first rule says that we have to find the product of their numerical values. So, first we will have to check the numerical values of these two integers. Because these two are positive integers, we will directly take 21 and 7 as the numerical values, and because 21 and 7 are also the numerical values, we will perform 21 into 7, and whatever answer we get, we will attach a positive sign to it because the rule 1 says that we have to add a positive sign wherever the two integers being multiplied have the same sign. So here I will add a positive sign, and this is nothing but 21 into 7 gives us 147, and so we've obtained 21 into 7 equals 147 with a plus sign appended. And so because there is a plus sign here, I can get rid of the plus sign and simply write it as 147. And so we've obtained the first answer, that 21 into 7 equals 147. Now let us apply the first rule to this fourth case. Now in this fourth case, the first rule says that find product of numerical values. Now the numerical value of minus 21 is plus 21. So I'm taking only the numerical value, and the numerical value of minus 7 is 7, and so I will take the numerical value again, and so I will find 21 into 7. And then because we are dealing in rule 1, we assign a positive sign to the product. So this product is again assigned a positive sign, and so we get the answer 147. Now note that in both these cases the same answer was obtained. So whenever we are multiplying two positive integers or two negative integers, we always get a positive integer as a result. Let us now look at rule 2, which applies to cases 2 and 3. Now if you look at case 2, then first integer has a positive sign and the second integer has a negative sign, which means that we have unlike signs or opposite signs, and so rule 2 applies here. Now applying rule 2 here, we will first write down that this is being solved using rule 2 because the two integers being multiplied have opposite signs or unlike signs. And now we can write this as, note that in rule 2 we have to find product of numerical values again. So the numerical value here is 21 and the numerical value here is 7. So I am not discarding the sign but only taking the numerical value, and so I will first find the product of the numerical value, that is this. But then because we are in rule 2 now, we have to assign a negative sign to the product. So this product that we obtain will be assigned a negative sign, and so I will get a minus sign here. And we know that 21 into 7 is 147, but there is a minus sign here which has to be preserved, and so the final answer is minus of 147. In a similar way, if you look at the third case, so the second case is being solved, but if you look at the third case, here 1 is negative and 1 is positive. And so the integers have unlike signs or opposite signs, and so we apply the second rule. So here we apply the rule 2. And now when we apply the rule 2 to this multiplication, the rule says that find product of numerical values. So we'll not consider the sign and find the numerical values product, that is 21 into 7. And then the product will be assigned a negative sign because we are in rule 2 now. And so negative sign will be assigned to this product, and so the answer will be minus of 147. So in this way, we can solve multiplication of two integers when one integer is positive, other is negative, or if both are positive, or if both are negative. So in all these four cases, we've seen how we can apply the proper rule and perform the multiplication of two integers. Well, let us now see how division of two integers can be performed. So we are talking about division of integers. So let me write here that I'm talking of division of two integers. So far we had seen that how we can deal with division when we are dealing with natural numbers or whole numbers. So now we will extend that concept and understand how to perform division of two integers. So suppose you have a question such as this, that is, you want to find 21 divided by 3. Well, so the question here is we have to divide 21 by 3 and find the answer. Now, note that because 21 and 3 are both whole numbers, you can very easily say that 21 divided by 3 is equal to 7 because we have seen division of whole numbers can be carried out pretty easily. Now, let us see another example wherein we have 21 divided by minus 3. So now the situation is different. Earlier we had both whole numbers being divided, or rather one whole number being divided from the other whole number, but now we have a negative number being divided by a positive number, or rather a positive number being divided by a negative number. So in this case, what will we do? Well, to solve such cases, we use one of these two rules that I've written here, which are rules for division of two integers. So let me write that. These two rules that I've stated here, rule 1 and rule 2, are for division of two integers. Now, before looking at the rules, let us understand how many cases we can get when we are dealing with division of two integers. Now, the third basic case that we can get is the first integer is negative, whereas the second integer is positive. And finally, we can have a case wherein both the first and second integers are negative. Well, let us look at each case one by one. When we have 21 divided by 3, then note that because these are whole numbers, we know the answer is 7. But if we do the same thing using one of these rules, then which one of these rules can we apply here? Note that because both integers, or rather these integers to which division is being applied, are both positive, and so they have like signs. So the sign of 21 is plus and sign of 3 is also plus, so we can use rule 1, which is for like signs. So here we will write that because these two integers have like signs, we are using the first rule. Now, the first rule says that we have to divide the numerical value. So whenever two integers of the like signs are being divided, or rather the division is being carried out between two integers of the like sign, then we divide their numerical values. Now, numerical value of 21 is 21 itself, and numerical value of 3 is 3 itself. And so when we divide 21 by 3, we know the answer is 7. And so here we get 21 divided by 3 is equal to 7, and so we've divided their numerical values. But the second step is to assign positive sign to the quotient. Now when we come to the second step of assigning positive sign to the quotient, note that the quotient was 7, and so when we apply a positive sign to 7, it becomes plus 7, which stays as 7 itself. So the first case gives us 21 divided by 3 is equal to 7. Now if you look at the fourth case, in the fourth case also, both the integers on which division is being applied are negative. So both these integers, minus 21 and minus 3, both have like signs because both signs have minus, and so we use rule 1, which is for like signs. Now, because rule 1 is being used, we will read out rule 1 once more, that is divide their numerical values. So we'll divide their numerical values, and numerical values are 21 and 3. And now I will divide their numerical values 21 and 3, and because we are in rule 1 now, we have to assign positive sign to the quotient. So now whatever answer we get, we will assign a positive sign to it. We've seen that 21 divided by 3 gives us 7, and whatever quotient we've obtained, we will assign a positive sign to it. Now, plus 7 is same as 7, so I can leave the answer written like this, and so we will get that minus 21 divided by minus 3 is equal to 7. So here again we applied the rule 1, because the signs of both the integers were same, in this case negative. Let us now look at the second case. In the second case, we have 21 divided by minus 3. So note that here the first integer has a plus sign and the second integer has a minus sign. And so the two integers have unlike signs, and so the second rule will apply here. So I will write that this can be solved using the second rule. Now, if I try to solve this using the second rule, then I will follow exactly the steps that are given here. This says that divide their numerical values. So first we divide the numerical value 21 by the numerical value 3. And on division we get the answer 7. But then we have to assign a negative sign to the quotient. So the quotient that we obtained was 7, and we are applying a negative sign, assigning a negative sign to the quotient. So this becomes minus 7. So this becomes the answer to 21 divided by minus 3. Next, coming to this third case wherein we have minus 21 divided by 3. Now the first integer is negative whereas the second integer is positive, and so we have unlike signs, and so we will again use rule 2 here. So I will write rule 2, and by use of rule 2 I can write we first divide the numerical values. So I will divide 21 by 3. So dividing numerical values gives me 7. However, I will now have to assign a negative value to the quotient, and so I will assign a minus sign, and so I will get this as the answer. So note that here I missed out a minus sign because we are assigning a minus sign to the quotient here, and so I will write minus in these two cases. And so my final answer will be 7 in the first case, minus 7 in this case, minus 7 in this case, and finally a plus 7 in the fourth case. So we have now seen how division of two integers can be performed.